Let me go to Phil Bouchard next. Phil has an update. So, Phil, I think you're doing an update on the gallium, right?
Yes, exactly. And a stack of other important, very important experiments that are not related to anti-gravity, but they're kind of energetic, kind of related to energy. Um, but first, I did introduce myself very quickly, but I wanted to say that I studied mathematics, computer science at the University of Sherbrooke, and I do have a freshman background in physics. So, so I understand the objective point of view of pretty much everything. So let me share my screen now.
Yeah, go for it.
Uh, okay, presenting Fornox here. All right.
There we go.
So
And it looks like there's something over part of it.
uh,
Oh, maybe it's your Zoom. Yeah, it's your Zoom window, I think, or something. I don't know. But
yeah,
yeah,
I think it's the control window of Zoom, but it just says Phil Bouchard anomalies September 2024. I've got four experiments I would like to share. Starting with the most important ones. First being the electrolysis. Second, anti-gravity. The third, the Cavendish experiment. And the last one, I'm trying to measure the frequency of a permanent magnet, but I don't think that's possible because it's too low. So first, the electrolysis. I did an experiment recently on the electrolysis, and I wanted to test a way to improve the generation of hydrogen, because the problem with electrolysis right now is that it's three times it costs, the input of energy required to generate hydrogen, which that we can use to generate a combustion. You need three times more energy than the output energy, so it's three times less effective. But if you increase the temperature of water by 13 degrees, then you're gonna generate 150% more hydrogen. So if you extrapolate to boiling point of water, then you're gonna generate 900% more hydrogen than the room temperature. So this is very important because it can easily replace fossil fuels, electric vehicles and all that. And what led me to think about this experiment is based on my theory that I'm not gonna talk about right now, but I'm just gonna resume very quickly that the atomic forces can be dilated by the linear charge density or the capacitance or the dielectrics of the material. And the only way to do that, it's pretty easy to increase it. You just add a capacitor, but to lower it, I'm not going to name names, but somebody told me, give me a hint that by changing the temperature, you're going to be able to lower the linear charge density. So that's exactly what I did. I cooled up the water, I heated it up, and I saw the big difference. So um, I'm gonna ideally we could just go to the gas station and order hot water, to to fuel your engines. That would be pretty effective. Or you use the radiators, the radiators, hot water. You use electrolysis on it. It creates water as a resulting combustion. It can be used like a cycle in a cyclic way. So that's the first experiment. Second one is the anti-gravity one. It was performed in a professional laboratory. I do not have the video and the exact detail of the resistance and the temperature and all that because I need to pay for the bill, but I do have the big picture. And on the left, you can see the gallium vortex. I'm using two magnets, two neodymium magnets of 1.4 Tesla each with 1.5 kilogram of gallium. And the dimension of the apparatus is around 11 the outer radius is 11 centimeters and the inner radius is around 5 centimeters or 6. So that gives an idea. And the apparatus on the left was stacked up on the support on the right, where we see three balances because there are three balances because we want to measure the precision of the experiment at the same time. So with that said, the results of that experiment is that with 153 amps of current, there was a weight shift of 2.6 grams. So around, like again, there was 1.5 kilogram of gallium, and we were able to see a shift of 2.6 gram of on the balances. The total of the three balances added up gives 2.6 gram. But it's right on the edge of the uncertainty of the measurement, the balances. So it'll have to be redone with a greater current, but at the same time, I was expecting something like that because it's an extrapolation of what I already done at home that gives something like that. So it can be a good starting point with to Mars Circle. I'm giving numbers here because it can be a good starting point to Mars Circle, and then is an improved version of this experiment. And so that's the anti-gravity and so that's about it. And here are the maths. Basically, I'm not gonna go through the maths too much, but for a distance of 0 meters, you have an acceleration of 0.02 meters per second, and that gives a mass difference of 2.6 kilogram, which is 2.6 gram. Sorry, 0.0025 kilogram or 2.6 gram, which gives an approximation of 1 times 10 to the minus 12 meters per kilogram for the gravitomagnetic permeability. This is the ultimate constant hidden behind everything here that I kind of I'm solving using the experiment. So I was 600 times off the what I thought it was. So maybe it still needs to be narrowed down, but that gives an idea. That's a relative gravitomagnetic permeability. That's not the absolute one. There's a big difference between the two. The absolute one is minus 27. The exponent is minus 27. So yeah, that's the hidden variable behind all this. And here's the Kevin. Sorry for the flash. It's flashing here. Sorry about that. I redone the Cavendish experiment of the Fell Forward Research Lab or Wayne Ohala. He had the great idea of doing the Cavendish experiment. I redone it using LED lights. So LED lights, they don't heat up that much, so it's not going to create a air pressure or anything like that, a differential of air pressure. So So we see the rod is being attracted by the light, and the idea here is that the energy potential creates, that's what gravity is. That's the same thing. Call it gravito-electric, gravito-magnetic, electric or magnetic or electromagnetic is the same thing. You have an energy potential, and it has the same effect. It creates a force or an acceleration. So that's the what I'm trying to promote here a little bit. But this experiment will have to be redone in vacuum to be 100% certain that there's no air heating up or anything like that. So if somebody has a vacuum box, a vacuum room that he can replicate this experiment, that would be a great experiment to replicate for the third time. So and I'm trying. My last experiment is, well, not my last, but another experiment is I'm trying to measure the permanent magnet's frequency, but that's impossible with the equipment I got recently, because I cannot go lower than 24 megahertz. So I anticipate the magnet's frequency to be 0.001 hertz, which is lower than a half wave. So why am I thinking that? It's because if we take the standard energy density equations, then you must have a frequency and a particle density. So you cannot have a null frequency or a null particle frequency, which is U in that case. So you need to have a frequency or n particle density to have a energy density. Call it a magnetic field or electric field is the same thing. So you need both of them, and also according to my basic calculation, a Tesla is some sort of constant times a frequency, and that constant is the number of kilograms per coulomb, or joules per coulomb, which is around 1121 joules per coulomb, which is based on the square root of the magnetic permeability divided by the gravitomagnetic permeability. So yeah, that's my presentation here. I'm pretty much I'm done presenting. So I don't want to go too much in the theory, but that's the result of the 4 experiments. I also did another one, which is a magnet with an interferometer, but it's so sensitive. I need to replicate that one for a third time. So yeah, thanks for your time, and thanks again, Tim, for giving me the opportunity to share all that. You're muted.